with the solar-based infrastructure which we have initiated, right? So this we have all these things we have covered, and we started this one, solar-based charging station, right? So in solar-based charging station, let me provide you the mic so that people can also ask the questions if you have any in this particular. How do we make the total, what we can say, total power plant of a solar. So if you talk about the solar power plant, so solar power plant, it is not only few panels which are involved in it, depending on the kilowatt rating. Suppose I'm talking about 10 kilowatt PV panel or 20 kilowatt PV panel. So according to 10 and 20 kilowatt PV panel, you have to add the series and parallel module, right? Series and parallel module. And if you add these series and parallel module at the right side, if you go to see, I have added few panels in series and few panels in parallel, so that the total voltage and current of a particular panel can be a particular, not panel, total array, we can say array, right? So as I told you, initially we have cells. One cell we have, and these number of cells, they are connected again in series and parallel to make a module. And one module, the voltage and current rating of one module, the voltage and current rating of one module, that is shown here. So we have 32.8, 8.3 ampere, and then if we add these modules in series and parallel, then we can make a array. Okay. Now, after that we discussed if we wanted to connect a battery, because in charging station, number of batteries which are connected, whether the battery which is resting on the ground or it is along with the electric vehicle. Because see, if you compare this charging station with the petrol pump, so if you compare this charging station with the petrol pump, in petrol pump or in some kind of this storage is there, whether you can fill a tank or some kind of storage where you can fill the diesel or petrol and you can store it and you can utilize it. In similar fashion, suppose sometimes solar energy is not available, and grid is also, I mean, it is fully burdened, and the lots of load which has been connected. Peak load demand is already there from the grid side. So solar energy is not there. Grid demand is also we cannot take, or let's suppose there is outage of grid. So you must have some emergency storage which can supply this energy when a vehicle is coming at the charging station. So see, energy storage we cannot ignore. Energy storage in a charging station, it is an integral part of this, right? So if you want to discharge this battery or we wanted to connect directly with the panel, so I told you we have to match the rating, right? Matching of rating is very important. So we cannot have like panel of 30 or some higher voltage, battery voltage is quite low, or the battery voltage is quite higher, panel voltage is quite low. Otherwise, what we have to do, we have to apply or we have to connect some interfacing device between panel and battery. That is commonly known as inverter or some other devices, not exactly inverter here, DC-DC converter we can say. Right? So that's why in between what people have done, they have connected the boost converter between solar and the battery. Right? Suppose, so if you can say, sir, we cannot connect battery directly with the PV panel, right? Because suppose solar rating is 32.8. Now battery rating is 48 volt. How do you charge this battery from this solar panel? This will not be possible because battery voltage is higher. So current will not take place from V1 to V2. When the current will take place, if we don't have any control over there, right? We have not connected any interfacing device between these two entities, then it will automatically, there is no flow of current, automatic flow of current will not take place. Right? So to flow the current in this particular case, what we have to do, we have to force the source, we have to force the V1 so that the current can take place from V1 to V2. Right? Current can take place from V1 to V2. Right? So,
sir, what is PV, sir? Sorry,
photovoltaic, PV, right?
Portable?
Photovoltaic.
Oh, photovoltaic.
Yes, photovoltaic. Generally, we used to call solar photovoltaic, right? Activated. SPV. We used to call PV. Solar photovoltaic. So here, this solar photovoltaic, this is connected via boost converter generally, so that we can do or we can perform. So there are different applications. What are the applications of this PV? We have different applications. We can install these panel in canal even, right? We can install these SPV based system we can utilize for space applications, right? Number one for this SPV array for canal, number one for space applications, right? Space applications. Third one, where we can use this for lightning, we can use, right? Oh, sorry, I have already written this. So for lightning, we can use this PV array. So even in case of lightning also, there are some, suppose we have certainly some LEDs, and this LEDs, I need to control it, right? How do we have these LEDs? LED array that are defined in a different way, right? We have arrays of LEDs, this way. This is the arrays of LED. Now we have to control this. We have to control the intensity of LED, which is powered from PV array, photovoltaic array, solar array. So in between, we have to use some interfacing device. We can power. So you might have seen the street light, right? A street light is made up of this various LEDs which are connected in a form of array. So how do we perform this? I mean, how do we control the intensity of LED? Suppose in morning time, or we can say in evening, between 6 to 7, right? The intensity of sunlight, it is quite low, obviously. So what we have to do, we have to have the intensity of LED as well as that must also be low. But as soon as we are approaching after 7 p.m., so we can connect battery directly with the PV panel. But this, what I am telling you, the application of this PV array, we cannot connect this, even though a street light directly with the PV array. In daytime, the battery is there, so we can charge the battery from the PV, and in night time we can have the LEDs which are connected with the batteries. Now the question is, how do we optimize this battery power? Optimization of battery power mean to say, if can we control this dimming off or the intensity of these LED which is there. So during, suppose some of the LEDs which are required, or the intensity of LEDs required low in the evening, however after 7 p.m. the intensity of light, full intensity of light is required. So what we can do, we can connect one converter in between, buck converter, boost converter, whatever the converter you can choose, and this converter itself, by controlling the duty cycle, it will control the intensity of this light. So what is the purpose I'm telling you? Because what is the purpose of telling this? We can control this battery performance, because as soon as the duty cycle I'm controlling the voltage, and I'm not wasting the battery power in these LEDs. So therefore, this way we are controlling the intensity of light, and we can successfully optimize the battery power in this. And similarly, other performance, MPPT and other we can utilize here. Right? Maximum power point tracking, and we can charge the batteries. Yes.
Can you explain that again, sir?
Yeah. So let me go to the next slide. Basically, how do we utilize this PV photovoltaic for street lighting? Do you know the lightning circuit? Street lighting circuit.
Sir.
Yeah. Just I'm going to draw this application. This is very important application. I hope you people are aware about the buck converter, right? And then we have battery. And then we can use buck boost converter. And then we have some LED array over here. LED array means again this LED array. Not drawn the circuit there, but here I'm going to draw this. This is very interesting application. This is LED array. And what is this? This is the battery. This is the battery. This, so you might have seen this is coming as a controller. This unit, it is coming as a controller. This unit is coming as a controller. And we are taking some voltage and current. We need to sense the voltage, VPV, and the IPV from here, and that is going in the MPPT. The output of MPPT, that is duty ratio. So we have the voltage, and we can take as a VPV, IPV.
So what is MPP? What is the full form of that?
Yes, I'll tell you in detail what is MPPT. Maximum power point tracking. The next topic is only on the MPPT, right? MPPT, because in multiple times we are using this MPPT controller while we are talking about the installation of solar-based charging station. Solar-based. Buck converter, because the battery voltage is 12 volt only, and suppose the panel voltage is 36, 32 volt. So what it will do, it will buck the voltage to 12 volt battery. Because most of the time, along with this LED array or in the street light, we are using 12 volt battery, right? 12 volt battery is installed, 12 volt or 24 volt battery is installed in the this. So the first converter is responsible to charge the battery in daytime, right? Daytime, because solar insolation it is available. In night time, this circuit is disconnected because energy it is not available from the PV array side. This is the PV array. PV array side. So the battery, again, it is going from the buck boost. So do you know the configuration of buck boost? I have already shown you. So inductor and two switches that are making this converter. Inductor and two switches. Correct? So after this configuration, buck boost, we have some voltage at the LED side. Now, suppose I wanted to control this LED and suppose I need not to give full voltage to this LED. So what we will do? We will apply a buck converter. This converter will operate in buck mode. So the voltage which is applied across the LED, that is very low voltage, and the intensity of light we can control. So depending on the solar PV and the another scenario condition, like intensity of this street light or LED can be adjusted from 0% to 100%, right? From 0 to 100%, this can be adjusted with the help of this buck boost converter, right? By automatically by using this DC-DC converter, buck boost converter here. So this is the important application related to, right? Important application related to solar. Right.
आपको फोन करो.
Any question? Please.
What is IPV and VPV?
Who's creating the issue? Please mute yourself, Abhinash.
Sir, what is mean IPV and VPV?
These are the two signals which we are taking from the PV array. IPV means the PV array current. VPV means PV array voltage.
So what is the meaning of array over here?
One by one. Yes.
So what is the meaning of array over here?
Array means, as previously I told you, we have first we have cells in a solar plant, and these cells, if they are connected in series and parallel, we are making the module. And various modules which are connected in series and parallel, then they are making a PV array. See, we cannot use a single module, because single module that is rated how much? 32 volt hardly and 8.3 ampere. So if I wanted to go for the higher voltage, I have to connect these modules in series or in parallel.
But normally, sir, I'm asking like if PV cells, like if it just comes with like 12 volt, okay, no. So like why would I go with the 36 voltage? In fact, if that 12 volt is available, then you don't need this buck converter or the boost converter for that.
So if you have 12 volt panel, you can use. Do you have 12 volt panel?
No, like I'm generally asking you actually.
No, but see, that's why I'm telling you now. There are some standard PV panel modules, right? So the voltage from these PV panel, I can show you. Let me show you a few modules so that you will understand. Just give me a second.
There is it standard models.
Yes, that's what I'm saying. Some OEM, they have certain standard.
32 volt, 8
Yes,
ampere.
yes. Let me show you a few slides. I hope I have these slides, so I can quickly show you few OEM who's making these modules. Let me go to yes, that's 4 slides. I don't know this. The background is coming blue. So what we can do? Yeah. So solar panel specification in detail. Suppose we talk about the BP solar. I hope it is visible, right? So if we talk about this BP solar 170 watt, 24 volt monocrystalline solar panel, which is made in Australia. Now, if you have 24 volt panel, you wanted to utilize this panel for street light for a 12 volt battery. How do you use? How do you use? We cannot use directly. We have to buck this voltage, right?
We require buck voltage.
Right. So for that, we have to use this buck converter. So you can see nominal voltage, electrical specification, if you go, that is 34 volt, 0.7 volt, 34.7 volt. Current, that is 4.9 ampere. Right. If you go to the next one, suppose this is another panel which is developed by Evergreen Solar. Right. So 100 watt solar panel, it is available. And if you see the voltage is 17.3. The current is 6.65. Right, and I'll tell you there are two voltages, one voltage at maximum point and another voltage which is there at an open circuit voltage or maximum voltage, maximum possible voltage. And you can see how do we make the panel? By having a various cells, number of cells for developing a panel or module. Panel and module both are same. So lots of cells are connected in series and parallel which used to develop the module. Right? Module is developed due to number of cells are connected. So here you can also see the panel voltage is 21.5. And then we have other panels which are there with a 110 watt, 65 watt, right, 30 watt panel, 50 watt panel, different panels are there. So that's why, and again, here you can find out the voltage is 21. Right. So in most of the cases, you would find out the panel power that is varying from 50 to 500 watt, if I'm not wrong, right? And the current or the voltage, it is varying from 17 volt open circuit voltage to 50 volt. So you will not find out. You can develop the panel voltage less than 17 volt as well, because as you can decrease the number of cells. But as soon as you are decreasing the voltage, the overall power will also be decreased, right? So people are used to make the peak power around. They are taking 100 watt for each particular panel. So that's why we are using the buck converter. I hope it is clear now.
Sir, like I have one more query, sir.
Yeah.
One for that actually. Sir, as you are saying that buck boost converter will sense that, and depending upon that, it will supply that amount of voltage to the battery. But my question is, instead of using this buck boost converter, I could use the transformer also, no? Like that is about the voltage that I want for the battery. I can use the transformer, the rated transformer for that.
So which transformer you will use? Can you
Normal like DC transformers I can use.
DC transformer, high frequency transformer you will use?
I'm not sure about that, but I can use the DC transformer, no sir. Like
so that's why I'm telling, suppose you are using only DC transformer, how do you control the maximum power from this PV array? See, this converter, it is not doing the function of converting voltage from higher voltage to the lower voltage. It is also extracting maximum power from this PV array. So it is optimizing the point. I'll tell you why this interfacing device, it is necessary to take the maximum power from this panel. So that's why this MPPT will come into the picture. Now, if you use a transformer, how do you perform the maximum power point tracking? Yes, you can do. You can boost the voltage by having some high frequency transformer, as you can. People are using in isolated converters, right? In isolated converters, you are using these systems where you can have the ratio of 3:1 or 1:3, 2:1, like that, and you can boost the voltage. But here we are not only boosting the voltage or reducing the voltage, but at the same time, we are also performing the maximum power point tracking from this panel. I hope you understood this issue. Correct? So here the task is not only for performing this, but also at the same time, we are going for an MPPT, not only for this.
Sir, here, why buck boost converter together here?
Yes. Now let's come to the second part. So I hope the first part is clear. Why the buck converter, right? So buck converter to reduce the voltage as well as at the same time we are performing the maximum power point tracking, which cannot be performed using transformer. Now why buck boost converter? Because sometimes the LED voltage, suppose we are having a 7 volt. We are at the evening time around 6:30 p.m. Right, 6:30 p.m. What we have to do at the 6:30 p.m.
We'll turn on the light, sir.
Right, we have to turn on the light, but some amount of sunlight is also available. So we should not go for the high intensity of this LED. We need not to turn on all LEDs or LEDs which are there at full intensity. So what we can do, we can operate this converter in buck mode, so that the voltage across or the power which we are taking from the battery, I told you initially, we have to optimize the battery nowadays. Right? Initially, we have used the battery and we have not connected any converter, and it was directly feeding whatever the current was coming. So at 6:30, the full LED light was glowing. But now, for half an hour, till the time we have intensity of light, this will operate in buck mode, and the intensity of light will be less. But as soon as the dark is increasing, the darkness is increasing in night. Suppose after 7:30, I will operate this converter in boost mode. So all the LEDs, the voltage across the LEDs will be a rated voltage. Right, rated voltage, and all the LEDs will be glowing at a full intensity. Now, let's talk about at again 12 a.m. in the night or 1 a.m. in the night. What I have to do, again, I have to switch off some LEDs, and I have to also down the intensity of light, because the number of people which are going or traveling in night, or the number of people are reducing on the road in the night. Right. So again, after 12 or 1 a.m., I can reduce the intensity of light so that I can save the battery power. I can save the battery life. So this type of converter, it is helping us to optimize the battery as well as the battery life in the evening as well as in the night time, while we need not to switch on all the LEDs. That's why the buck boost converter, it is required to control these LEDs here.
But sir, like, how can it be possible on a running roads? Like, if you take any highways and all, like, there will be a vehicle that will be running 24 hours on that road.
I'm talking about street road and street lights. I'm not talking about highway or some particular place where we require continuous light. In a street light, suppose the full intensity of light is not required. I'm telling you just application. It is up to you. You can choose that application or not. So this could also be, it is very good for your home as well. Right, automatically, if lights are you having this control, like it is sensing the darkness, and according to darkness, this is increasing or decreasing. You may consider your street light on the road where there is no. See, if you're considering the highway or where the continuous vehicles are coming and going, that way we cannot do. We need a full intensity. That we cannot avoid. But your pathway where people are mostly, they are roaming until 10 or 11 a.m. and we can control the intensity. It is not like that; it will be completely off. Right, some of the intensity of light will be there. Right. It is not like that. It will be completely dark. LEDs are shut down. No. So that is the application. We can have and we can utilize it. But yes, in highway we cannot utilize, obviously.
And sir, in a highway also, like, instead of the buck boost converter, like, as in a highway, there is that the cars, the vehicles 24 hours, there will be running on the road. So like, as you said, like, after during the evening time, if little sunlight is being there, like, I don't want to use the 100% intensity. So
Right.
instead of buck boost converter, I can use that DS sensor. No, sir, that is also the best option, like daylight sensor.
But how do you control the battery current and battery power? DSL will not control the battery current, right?
DS sensor, so daylight sensor. I'm speaking of.
Yes, daylight sensor you can use, but how do you control the battery current? How do you control the battery voltage? That is not there. Sensor,
Okay.
sensor, you can sense the light intensity and you can glow the LEDs. But at the same time, you have to get the voltage and current from this battery. So you have to also take care of this state of charge of the battery, depth of discharge of the battery, all these things, which is inbuilt in this buck boost converter.
Okay, I got it.
Yeah. So this way we have this different application. Now, if we connect these, so as I told you, if you are connecting panels or modules, I already told you, modules in series. So voltage is additive. Right? Voltage is additive. So suppose one cell has 0.5 volt. Right? One cell has 0.5 volt and we made this type of cell. Now, if you connect these cells, various cells, suppose we have one cell which is connected in series with another cell, third cell, fourth cell, like that. Now, if I measure the voltage across these cells, what would be the voltage? So how many 0.5, 0.5, 0.5, 0.5. So what is the total voltage? 2 volt. Right? 2 volt will appear across this. So this way it will use to make the module. Single solar or module, which is a combination of several solar cells which are connected together to generate more power. Right? So we have different types of module. Now, if I'm adding this in series, right? Suppose 2 modules that are added in series. So this is the array, or this is the one module which we are talking about. One module. Now let's talk about 2 modules or 2 cells, whatever you can consider. So the if you have one module, the IV characteristic. I'll tell you how do we draw this IV characteristic. For time being, you can consider this is the IV characteristic, right? IV characteristic of a module. So what is the maximum voltage? That is 0.5. So we will go with the let's suppose this is drawing 0.8 ampere current. So we have 0.8 ampere here, right? 0.8, and the maximum voltage, that is 0.5 volt. So we have 2 particular what we can say signals or component, or you can say these voltages and current. So we have one known as, that is open circuit voltage, and second one is known as maximum operating voltage, or voltage at MPP, maximum power point voltage. So open circuit voltage generally people are representing as a VOC. However, the maximum operating voltage that people are representing as a VMPP. So if you draw the characteristic here, how do we draw this characteristic? We will have, for a single module, this characteristic is coming something like this. There will be some this type of slope will be there. So this is for single cell. Now if I have added 2 cells, how this characteristic will change? Suppose I have added 2 cells in series. So the voltage will 0.5 volt and it has 0.5 volt. So total voltage will become 1 volt. Okay. So earlier we were having 0.5 volt, but now the voltage is increased to 1 volt. So the previous characteristic, but you will find out the current which is there at a same point. Current is not going to increase. So from 0.8 we are going to have this characteristic, that is the previous characteristic. But now as the voltage is increased from 0.5 volt to 1 volt, so my characteristic at current it will be same. Right? At 0.8 it would remain same, but as soon as it is moving toward this voltage side, the characteristic is going to change. So the original characteristic will be like this. However, the previous characteristic which was coming at 0.5. Are you able to follow? So the current is not going to change from the characteristic point of view, but the voltage is changed as the 2 cells are connected in series.
Sir, why the current will change, sir? As it is connected,